Good afternoon, ladies and gentlemen. On behalf of Ohio University's Voinovich School of Leadership and Public Affairs, I'd like to welcome you to the first installment of our 2014 Energy Webinar Series, a continuation of the successful webinar series we hosted throughout 2013. My name is Alyssa Welch, and I'm a project manager with the school's Consortium for Energy, Economics, and the Environment, also known as CE3. Today's webinar, entitled Ohio's Landfills, Waste Management and Emissions Opportunities, is made possible through a grant from the U.S. EPA to help Ohio stakeholders better understand the emissions implications of their energy options. The grant activities for our project includes workshops and webinars such as this one to discuss current trends in Ohio energy and emissions. Also under this grant, Ohio University maintains an online database that we created to track and analyze emissions statewide, including those from point and non-point sources. Today's webinar will discuss the trends in waste management in Ohio, the waste, energy, and emissions nexus, and how companies and communities are working to balance compliance obligations, sustainable environmental practices, and innovative technology choices to reduce their waste, energy, and emissions footprints. Developing long-term management solutions requires a forward-thinking approach to how we traditionally think about waste and energy, and our expert panelists today will be sharing their strategies and goals to accomplish this. On behalf of the CE3 team, I'd like to extend my sincere thanks to all of our speakers today. I have a few logistical responsibilities in opening up today's webinar. First, if you have a question to submit to our panelists or our staff during the session, we ask that you type it into the question field on your GoToWebinar navigation pane. We will try to get as many questions answered as possible after the presentations have concluded. Second, we'll be emailing a link to a brief online evaluation to you after the webinar, probably in the next day or two. Please take a few minutes to provide us with feedback from today's session so we can make future sessions even better. And finally, a recording of this webinar will soon be posted at our website at www.ohio.edu/CE3 in the Resource Center section. Watch for more information about our upcoming webinars. We're in the process of planning several more this spring, including one on the changes in Ohio's electricity market for 2014 in the last week of March, and a session on how global climate and emissions research impacts Ohio for late April. It's now my pleasure to introduce our moderator for today's webinar, Mike Loong. Mike's the president of Resource 100 Limited, a consulting firm with a focus on waste reduction, recycling, and the conversion of waste to products, fuels, and energy. He's also the network leader for the nonprofit Ohio Byproduct Synergy Network, an organization devoted to turning waste into value. He's the founding director of the Solid Waste Authority of Central Ohio, or SWACO, and served in that position for 18 years until he retired from public service in September 2007. He has a total of 40 years of public service at the state, county, and city level, serving 16 years with the Ohio Department of Transportation and 6 years as the Director of Public Utilities and Aviation for the City of Columbus. Mike is also the former chairman of the State of Ohio Recycling and Litter Prevention Advisory Council, a former member of the State Solid Waste Advisory Council, a past president of the Buckeye chapter of SWANA, the Solid Waste Association of North America, the 2003 recipient of the SWANA National Leadership Award, and the 2007 recipient of the MORPC Regional Leadership Award. He's a graduate of our own Ohio University with a BS in Industrial and Systems Engineering and has completed advanced work at Ohio University and the Ohio State University in the same. He's a 41-year registered professional engineer in Ohio and a SWANA certified recycling systems manager. He currently serves as the secretary and treasurer of the nonprofit organization Sustainable Ohio. Mike, let me take a second to key up your slides here, and when you're ready, take it away. 1 second here, let me key you up. All right, Mike.
Okay, well, thank you very much, Alyssa, and welcome everyone. Let's wake up my slide here. There we go. So to find out where we are going with this issue, I I thought we ought to just take a quick look at what the regulators are doing, US EPA and Ohio EPA specifically. And if you look at the first slide, we see that the EPA, the US EPA, is clearly moving away from strictly waste management and recycling into a vision of materials management. And if you look at the bullets on the slide, you'll see some key words there, tying the economic and environmental aspects of this to our future, striving for more competition, and the use of sustainable materials. And they have a roadmap which is worth taking a look at when you go online to their website to look at their sustainable material management, the road ahead, where they have quite a robust discussion of this issue. But clearly you can see it's about using less materials, reducing at the source, trying to reduce toxics, and recovering more materials used. And that recovery not only is materials but also things as fuels, gas, and ultimately the production of electricity and other power. Now if we look at the Ohio EPA, they've recently developed as part of their what's known as their 592 review process, they have came out with a vision statement for the year 2035 and beyond. And I should point out that this is a draft for discussion document. It's online at the EPA website, and it's a very again a very ambitious look to the future. And they key point here, I think, is the last line where they believe that landfilling will continue to be practiced and needs to be practiced, but at an ever decreasing rate, while as a state we move towards zero landfilling. The the landfill is not going to go away anytime soon, and so we must recover materials and resources while we turn down the faucet on landfilling, not only in Ohio but across our nation. Okay. This next slide, the basic premise that I've been working under with our byproduct synergy network is that the waste from one company could become the food, the raw material, the feedstock of another company. And that's a pretty powerful concept when you think that you could have collaboration going on between peers where that heretofore waste material is now something of great value and can be used to either increase the profit or reduce the cost of another company. Slide here because it shows one strategy of hundreds that will be developed over the next 20 to 30 years as we as a society continue to figure out how to move away from landfills as our choice of how to handle our what used to be waste material. Now to help us understand this better, Alyssa has put together a great panel of participants, and I'm going to introduce them, all of them at this time, and then they will each go into their individual presentations. So first up today we have a team from Waste Management Incorporated. Kathy Trent is the Government Affairs Director for Waste Management Incorporated, where she has worked in numerous capacities since 1986. Kathy brings a wealth of experience managing complex environmental and public policy issues to her work in government and regulatory affairs, environmental management and permitting activities, media relations, and communications. She is recognized as a leading industry spokesperson in waste-related issues, having gubernatorial appointments to state advisory councils, executive committees, and is a Distinguished Service Award recipient. Kathy holds a Bachelor of Arts in Environmental Studies and a major in biology from Bowling Green State University, and pursued her graduate studies in environmental science at Miami University of Ohio. She is the chair of the Ohio National Solid Waste Management Association and is an Ohio Board of Governor member for the National Solid Waste Management Association. Kathy is going to present to us today on trends in waste management, and that's the company, and trends in waste management, the industry. And then following Kathy, we're going to hear from Paul Pavor. Paul is the Vice President of Waste Management Renewable Energy LLC in Houston, and he's been with that company since 1994. The Renewable Energy Group manages 74 landfill gas energy plants that are owned by the company, including the operations, business transactions, construction of new projects, and marketing of the renewable energy. Mr. Pavor has a Bachelor of Science in Civil Engineering and a Master's in Geotechnical Engineering, both from the University of Texas in Austin. He has 33 years of experience in various aspects of municipal waste industry, and prior to joining Waste Management, he was a consultant for 13 years and provided municipal solid waste services in the permitting, design, operations, and compliance monitoring. Paul is going to talk to us today about identifying landfill opportunities and solutions to produce energy and achieve greenhouse gas reduction. I think of this will be a kind of landfill gas energy 101. Following Paul will be Steve Giles, who is the Vice President for Alternate Energy with the consulting firm Hall & Associates Incorporated. Steve possesses extensive business development and financial experience. He has more than 25 years of experience encompassing a wide range of business development activities, including project development, mergers and acquisitions, and divestitures. He leads the alternative renewable energy activities for Hall, and he has successfully developed solar, biogas, and other renewable energy projects. Steve has worked in both regulated and unregulated electricity energy markets, including energy markets in Europe, Asia, and South America. He has a Bachelor of Science with a double major in accounting and finance and a Master of Science in business administration from the University of Dayton. We're going to hear from Steve on particularly a case study on landfill gas energy involving the Hardy Road landfill in the city of Akron. Last but certainly not least, from Kyle O'Keefe, who's the Zero Waste Initiative Coordinator for Rural Action and the Appalachia, Ohio Zero Waste Initiative. He works with regional, public, and private partners to improve waste reduction and increase resource recovery by enhancing public awareness, making sure that there's appropriate infrastructure, growing market-based opportunities, and supporting informed policy. Kyle serves on the board of the Association of Ohio Recyclers, and prior to joining Rural Action in 2010, Kyle taught resource management at Hawking College, and he served as manager of the Virgin Islands Sustainable Farm Institute on St. Croix, U.S. Virgin Islands. Kyle will talk to us as Ohio is moving towards zero, what's next and how do we get there. And in that regard, Kyle's also going to give us a quick look back at how we got to where we are today. So without further delay, I'm going to now turn the mouse over to Kathy Trent.
Kathy, you should be all set. Kathy, you may still be on mute. Could you unmute your line?
Thank you, everyone, and Alyssa and Mike. And this afternoon, I'd like to walk very quickly through some topics that I think will lead you to the ultimate discussion you'll have from Paul on landfill gas and renewable energy. Alyssa, I need to move to the next slide.
Try now, Kathy.
It's not letting me. So can you take control?
Absolutely.
This is a quick snapshot of the different environmental solutions that waste management offices are customers across the U.S. As you can see, we're not just related to landfills. We offer a variety of services, not just collection and recycling. We operate waste-to-energy facilities. We also handle organic processing, both composting and other types of facilities. And if you can look at the bottom left slide, you will see that we have a lot of sustainability facts about waste management collectively. You can see that we power close to over 1 million homes every year with our energy. You can hear more about that energy service from Paul in a few moments. And it says that we manage more than 10 million. This was a fact in 2012. 2013 data is being compiled and populated, but we're close to almost 13.5 million tons of recyclable commodities that we collect and provide back to manufacturers for their reuse. And we have a significant number of acres that we dedicate to wildlife habitats throughout the country. 100 of those are here in Ohio. Next slide, please. Waste management's one of our primary missions is try to extract the highest value we can from the materials our customers try to ask us to manage. As you can see from this slide, we have goods that the folks manufacture, they discard it, we collect it. But then the next half of the slide does present not only the recycling effort that we go through, but the investments that we've made in different technologies that we see coming down and towards the future. We have post-recycling processing where we've invested in different technologies that we are working on right now to a scalable and technology viewpoint to see whether or not we could sort it to manufacture electricity, fuel, or a chemical. We've got a lot of plastics in the U.S. that need to be recovered, and we're looking at technologies that could help us do that, as well as moving into how do we manage organics. We do have facilities throughout the United States. In Ohio, we're partners with the Garrett Corporation. And then finally, we have organics going to fuel electricity and the production of other type of materials. The final topic will be landfill gas to energy and waste to energy, which Paul will present more on. Next slide. If you want to look at the concept of how you can move towards zero waste, one of the things I'll ask you to think about today is not just the concept of zero waste, but moving beyond it. There really is a trend in the United States about thinking more broadly about the materials management and the overall greenhouse gas emission reduction goals that the U.S. EPA and various states have placed. When you start to look at materials management, you can see that there is a real connectivity not only between the solid waste that's being generated, but the amount that's being recycled, the energy and transportation fuel that can be collected and produced from that. And you're going to hear this afternoon a little bit more about how we in waste management take the landfill gas that we have to control for environmental reasons and move that towards the production of gas to energy. And then the final bullet, as I'm sure we will hear more later on this afternoon, is there's a lot of state and local solid waste policies in Ohio as well as across the country that can play very key roles in how ultimately global environmental implications from moving towards zero waste and beyond that are implicated. Next slide, please. The one thing I'll take away today that I'll ask you to take away is when you look at greenhouse gas emissions and how we in waste management try to reduce our footprint, one of the big things that we are doing is replacing our collection vehicles with a natural gas fleet. And as you can see from the bullets replaced here, or on the slide here, in 2012 we have approximately 2,000 natural gas trucks at 40 sites in 22 states and 2 in our Canadian provinces. And we're building close to 25 natural gas fueling stations each year. Here in Ohio, we have a fueling station at our Columbus collection office, as well as a green fleet servicing Columbus. We are going to bring on board in 2014 our Dayton fleet, and then looking towards Cleveland area for beyond 2014. So we have made investments in Ohio to try and move towards a very green fleet servicing our customers. Next slide, and now I'm going to turn it over to Paul so he can talk about landfill gas projects, how we're doing those throughout the country and in Ohio. Paul?
Landfill owners and operators provide a service to the community for collection and disposal of waste, and the first priority is environmental protection as well as safety, and that extends to the landfill gas component of the landfill. Landfill gas is generated from anaerobic decomposition, consists of about 50% methane, the rest being carbon dioxide and some nitrogen and oxygen, and we're required by regulation to control the landfill gas. You can see those listed here: off-site migration, groundwater contamination, odor control, as well as emissions through the cap. And when we select as well as operate a renewable energy project, it has to be implemented with the first understanding that environmental protection is the first priority. So it could affect what project is selected as well as how we operate the project. Whoop. And I have the power. Landfill gas collection, we drill wells into the waste, 3-foot diameter, perforated pipe. Each of these wells is hooked up to a header pipe. A vacuum is placed on the header pipe to withdraw the gas, and if we are not producing renewable energy, the gas is essentially wasted. It's flared. Most common types of projects, landfill gas is methane, natural gas is methane, so any application using natural gas can also use landfill gas. The ones I'm going to talk about are power projects on the landfill using landfill gas. We can also build a pipeline between the landfill and an industrial plant where they offset coal or natural gas usage, and in high BTU, the landfill gas can be stripped of the carbon dioxide and nitrogen and other contaminants made into pipeline quality and put in a natural gas pipeline. Landfills that are large enough to support a power plant typically are required by regulation to put in a collection system. And because this is not voluntary, then there are no carbon offsets generated. And so logically, if you have to put in a collection system, whether you destroy that gas in a flare or in engines or in somebody else's boiler, the destruction of that methane also does not qualify for direct carbon offsets. However, by producing electricity, we do offset power that would otherwise be generated through fossil fuel, and so there are indirect offsets that result from building a landfill gas to energy plant. It varies with the location. If you are offsetting coal, there are more offsets than if you are offsetting natural gas, and obviously there are no offsets for hydro or nuclear. So EPA has divided the subregions and calculated an average pounds and megawatt hour of energy production of the CO2 equivalent emissions for that area. Ohio subregion has an average about 1,520 pounds per megawatt hour, and across the country it ranges from about 500 to 1,800. So Ohio is in generally the probably upper third of emissions off greenhouse gas emissions. Here's a list of projects that Waste Management has in Ohio: 3 power plants, 2 high BTU plants. Stony Hollow and Cuyahoga are owned by third parties. We deliver the landfill gas to them, and they process it. And the others are owned by Waste Management. You can see the number of buyers we have there. And then the calculated indirect greenhouse gas offsets are based on the actual 2012 production and then using the Ohio average emission rates in pounds per megawatt hour. Whoop. Sensitive here. And a lot of information on this, but the message here, EPA requires us to report our annual greenhouse gas emissions. 1,200 landfills represent about 2.5% for all the reported sectors. We report on 240 landfills, 214 with gas collection, and then quite a few gas projects. So we have to meter and measure all of these. Reports are due every year by March 31st, and our lessons learned on this are it's a time-consuming process. EPA is not always ready for us to report, so it makes getting the March 31st deadline a challenge sometimes. And Waste Management is now in the process of putting SCADA systems on every blower and meter and third-party project, so that we can automatically load all of this up into a central report and do this all automatically. And I'm going to fly through these. This is the suburban landfill gas to energy plant. Through the process, this compressor skid filters and dewaters and compresses the gas before it goes into the engines. Next is the engine room. There it is. We use Caterpillar engines. These are the 1,000 horsepower engines. They also have available the 2,000 horsepower engines, doing analysis on the engines. The switchgear room, converting electricity to the utility requirements. I apologize. I'm using my little roller thing on the mouse, and it's pretty sensitive. These are reciprocating internal combustion engines, so they have radiators and mufflers just like you do on your car. Transformer converts it to utility line voltage, and then transmission line. We build our own connection lines to the transmission distribution line. Real quickly here, a comparison of landfill gas with wind and solar. Basic message here, we're distributed generation and base load power, finite resource, whereas wind and solar certainly have more capacity. Solar is an excellent distributed generation, peak load generation. Wind can be good. Very often it's providing power when it's not needed the most. So I think we compare well with the other renewable energy resources. You got to have a total portfolio in here for a total system. And then finally, the loop, picking up the waste, bringing it to landfill, and then delivering power to those homes. And that's it.
Thanks, Paul. I'm going to transition it over to Steve now. Thank you both, Kathy and Paul, for the presentation. Steve, give me one moment and I'll key up your slides. You should have control now. You are on mute. There you go, Steve.
Yes, hello. This is Steve Giles from Hall Associates, located up here in Dublin, Ohio, and happy to participate in this event today. Here we go. We focus in 5 market areas, and they all overlap. This is a great topic for us. The company was actually started over 30 years ago as a waste management consulting business, doing landfill design, permitting, post-closure compliance, leachate management, all those things associated with operating landfills. We're also heavily involved in the shale oil and gas market. I won't get into all of the details, but we work with both exploration and midstream companies. In the brownfield sector, we do go into old industrial sites, do environmental analysis, develop remediation and cleanup plans. And really, one of the things that's a little unique to Hall is we at times will take asset or risk positions in projects, and brownfields is one of the areas that we do that. We will take ownership to real estate, contaminated real estate properties or distressed properties, and clean them up for redevelopment. We have an environmental group that supports all of the above, doing a wide range of environmental analysis, wetlands, ecological services. And then I headed up the alternative energy group, which encompasses renewable energies. We currently operate 3 solar projects. We have supported various wind development companies as far as their Ohio Power Siting Board process. We also operate, which we'll talk about here in a minute, a landfill gas energy project, and are currently in the process of expanding into combined heat and power. I think, having been in the energy business now for about 30 years, I think the first line is really, the crux of everything. All energy projects begin with the fuel source. So really understanding your fuel source is critical. And when you think of a landfill, it's that landfill is your fuel tank. All landfills are not the same. And so really, I think Paul touched on this, why do landfills install gas collection systems? Because not all landfills have them. They get size. There are certain regulations, Clean Air Act regulations, that if you're at a certain capacity and emissions, that you have to have an active gas collection system in place. There may be times at which you have an EPA, or in this case Ohio EPA, order to control gas migration, potentially odors or other issues. Again, you're required then to implement a system. Those systems could be passive or active, again, depending on the nature. A passive system is essentially one where you are capturing the gas, a sophisticated collection system, and venting that gas into the atmosphere. Sometimes you'll see that for smaller landfills to help gas migration issues. An active system is one at which you have a more sophisticated collection system. You're capturing that gas, and then you're destroying it through a flare. So when we look at landfills, efficient collection systems are critical to successful landfill gas to energy projects. I can't stress that enough. Good design, good components, and the right balance in the system. Another important thing to realize is that it can be difficult to economically justify landfill gas to energy projects on landfills that don't have a collection system. You drive by landfills all the time. You see, a mound there, and some of them may even have passive vents, but there's no energy system, because the incremental cost of trying to fund not only the equipment to clean and utilize that gas to create energy, when you add on the additional cost to actually put in a landfill collection system or gas collection system where one doesn't exist, normally makes the economics unattractive. So and that may change. We know that greenhouse gas regulations are changing annually, and there may be times that some of these smaller landfills that currently do not have systems are required to install those. So we expect to see landfill gas to energy projects continuing. And again, as I said, not all landfills are the same. The quantity and quality of waste placed in a landfill will impact your gas production. Landfills that take, some C&D waste or things like that will have a different makeup than those that don't. Some landfills are strictly for construction demolition waste, which don't create, landfill gas that's usable. The landfill design and CAF can also impact gas production. And one of the interesting things about gas production is that, you know, weather, moisture, and barometric pressure will impact your gas production. When you see high pressure systems coming through, you can see a decrease in the amount of gas producing at the same time. It gets suppressed deeper into the landfill due to just the barometric pressure. So the complications of analyzing this landfill gas is a lot more challenging than obviously if you're just buying natural gas off of a pipeline. The other thing you have to take into consideration is that gas production declines. On average, 3 to 4% per year after it reaches its peak production. Typically, you know, the degradation process results in peak production sometime around 5 to 7 years after the waste has been placed. And that from that point forward, you know, it's continually declining. And again, when you think of a big landfill, it's got waste placed into it, you know, every year for 10 years. So you have a real mix of gas production happening at different parts of that landfill. And so really the challenge for companies like ours that develop landfill gas energy projects is trying to quantify, you know, the quality and quantity of that gas and trying to size equipment, you know, that is suitable for the landfill gas production. You know, the process involves, you know, actual testing, basically, you know, going out to, you know, each of the wells, doing gas sampling to see, you know, what level of methane is coming out of there. We look at the main flares to look at what the volume is. And again, we're not only testing just for the methane, but we're also trying to determine what are the other constituents in that gas. Landfill gas is typically, you know, 50% methane, 40-some% carbon dioxide, and then has other components in it which can create issues in your process. So we're going to just talk briefly about a particular project, kind of a unique project that we did in the city of Akron. The Hardy Road landfill is located in Akron, Ohio. It was actually closed in 2002, and it encompassed about 103 acres. During the height of its operation, it was taking in about 2,100 tons of municipal solid waste, you know, about 900 of it from the Akron area and about 1,200 from the Cleveland area. A collection system was installed in 2006 primarily to deal with gas migration issues. Again, this is one that was small enough that it didn't meet the new source performance standards of the Clean Air Act, but there was gas that was escaping the landfill and going into you know, neighboring areas. And so a gas collection system was put in. The system consists of 42 wells and approximately 2 miles of underground pipeline. The cap is about 5.5 feet thick, consists of clay, dirt, and a synthetic liner. So a good gas collection system was put in, and it has a good cap on it, so it is conducive to producing gas. We stepped into this project because back in the 90s, there was another company that had attempted to do something with the landfill gas, but they were trying to run it into boilers, I believe, but for whatever reason were unsuccessful. And so the gas had been flared for really 7 years, and we worked out an arrangement with the previous owner and the city to come in and step into the project. And again, by landfill gas energy projects, this is on the smaller side. We're seeing gas production between 300 and 500 standard cubic feet a minute, which is, and the methane, again, it varies from 46 to 52%. Again, things that you have to take into consideration. This is not a constant flow, constant mix type of gas. The engine systems have to be able to adapt to that. Luckily, this gas was reasoned in hydrogen sulfide and siloxanes. These are two of the key contaminants, I will call them, that you have to test for when you're analyzing the gas, because they will significantly impact the operation of your engine. And so, we have some passive cleaning of these things. We did not invest at this point into an active sulfur or siloxane removal system. And again, we test our gas on an ongoing basis. May have to make modifications if we see either our emissions or our engine performance being impacted by them. We did install a gas conditioning skid to manage temperature and moisture of the gas to improve the combustion process. And then we installed a 4,000-foot pipeline to transport the gas to the next door to the Akron Water Pollution Control Facility. So it's kind of an interesting project, and I think we have a picture of it. Yeah. That big green area on the right-hand side of the slide is a landfill, and you see the kind of roads, and along the tree line there's like a white building. That's where all the collection and cleaning equipment is located. And then a pipeline goes over underground, back along the river you see there on the left, up past those clarifying tanks, and then into one of the buildings, kind of in the center of the picture, where we have placed an engine and generate power for the wastewater treatment plant. So it's interesting, we're using the City of Akron's trash to actually clean their water. So we think it's a pretty cool project. This is the engine that we've utilized. It is a 16-cylinder, 42-liter GE Waukesha 1.1 megawatt engine. It is a big engine. In the picture you see, I think it's probably about a 6-foot step ladder there in the back right-hand side, just to give you some size perception. And this is the actual engine installed in its brand new condition, nice and shiny. The project cost approximately $2.7 million. Again, it's a 1,100 kilowatt capacity, or 1.1 megawatts, capable of producing approximately 8.4 million kilowatt hours per year. And right now we are providing approximately 40% of the electrical energy needs of the water pollution control facility. Just to put it into comparison, that would be enough power to produce energy for about 700 homes. Another interesting aspect, similar to what we talked about, us taking asset positions, our company raised all of the capital for the project. So the City of Akron had no out-of-pocket expense. They then purchased the energy at a rate, sorry for the typo there, 5% below service supply. So they were cash positive day one on this project. And you're seeing a lot more third-party development, especially for municipal landfills. Obviously, companies like Paul at Waste Management that manage them, they've done an excellent job on their own landfills, and obviously also provide services to others. Greenhouse gas, I have a schedule which we'll go through next. I think Paul again touched on this. Is that this landfill was already destroying the landfill gas through its flaring, just not an effective way to destroy the landfill gas. But by utilizing that landfill gas, we do get incremental greenhouse gas benefits, because we're offsetting fossil fuel generation that the wastewater treatment plant would have otherwise been using. And when you look at carbon offset calculations, methane, is equivalent to 21 tons of CO2 emissions. So it is, a very, very serious greenhouse gas when you put everything into perspective. This is actually an actual calculation, an emissions calculator that was developed by the EPA and a few others for the landfill methane outreach program. And it's kind of interesting. It goes through and helps you quantify the impact of those greenhouse gases. And so when you look at it, the direct emissions, which is really what the flaring would be doing, is reducing about 2,200 tons of methane per year, and so that's an equivalent. If you look at it go to the bottom line there in that chart where it says CO2 emissions, gallons of gasoline consumed. So just by capturing that landfill in the landfill and just destroying it, by flaring it, you're offsetting 4 million gallons of gasoline consumption. And then when you go to the middle column, the avoided equivalent emissions reduced, that's really then showing that because we've taken that next step and are utilizing that gas to offset fossil fuel production, and again in the Ohio region it is predominantly coal. Again, just using it in the gasoline ranks, that's another 500,000 gallons of gasoline that we're offsetting. So this project is reducing methane by 2,200 tons of methane per year. It's reducing, further reducing CO2 emissions by 5,000 tons a year, and in combination, the environmental benefit equivalent is about 5.2 million gallons of gasoline a year. So you can see the importance of looking at these systems and finding a way not only to capture that gas, but then to efficiently use it. I think that will conclude my presentation.
Thank you, Steve. One moment here and we'll get Kyle's presentation going as well. And some great information there about your landfill project. Appreciate all the detail. Kyle, you should have control now.
Thanks, Lisa. For my presentation, I won't be speaking about emission opportunities, but rather giving some perspective and background on information on Ohio landfills. As Kathy, Paul, and Steve have been discussing, landfills are important and necessary, and they're going to be around for a long time. And so we absolutely need to manage them with best practices, which include capturing methane and using it as an energy resource. But that being said, we view these landfills just as sustainable energy sources, and we've got to continue to find ways to reduce our dependency on them. So just some interesting facts to keep in mind as we move through this presentation. These are 2 points from the Stop Trashing the Climate report that was created a few years ago by a few partners that we've worked with, including the Institute for Local Self-Reliance, EcoCycle, and the Gaia organization. The first point basically states that all the manufactured materials that end up in these landfills are tied to extraction, transportation, processing, and manufacturing, which combined represent almost 37% of the U.S. greenhouse gas emissions. So keeping those materials out of the landfill will help to reduce those emissions ultimately. And the second point may seem obvious, but states that landfills are the largest source of human-generated methane in the U.S., and that over a 20-year time frame, methane can be 72 times more harmful than CO2. So that report is online and easy to find. Check it out if you haven't already. I also wanted to share the fact that it's really unknown how much waste we generate in the U.S. And so this graph represents 2 of the major sources of information on waste and recycling in the U.S., which include both the U.S. EPA and BioCycle. And I won't get into the details about the different methods for the studies, but you can clearly see that the BioCycle study shows the U.S. generated an additional 128 million tons of landfill and incinerated waste compared to the U.S. EPA study. So you can just see there's an imbalance in really knowing how much materials are ending up in landfills and the true impacts that they're having. When it comes to Ohio landfills, we currently have 38 active licensed landfills. Remaining years or lifespan for those landfills range from just over a year to 88 years. And so there's an average of about 35 years left per landfill. State law also requires that landfills have to be maintained for 30 years after a landfill is closed, although no landfills have actively been closed for 30 years, so it's hard to tell if that's even long enough, but landfills continue to generate methane, so having in place systems to capture methane and use them as energy sources is critical. In 2012, almost 22 million tons of materials went into Ohio's landfills, and this graph kind of gives a breakdown of some of the categories for those materials. This information also comes from the Ohio Facility Data Report, which you can also find that on Ohio EPA's website. And in the graph, you can obviously see that general municipal solid waste, the stuff that we end up disposing, in our homes and businesses, is the highest amount of material that ends up in our landfills, followed by industrial waste and then construction and demolition. Another interesting note is that each of these categories have dropped in tonnage from the previous year as well. I also want to point out that Ohio is a top destination for out-of-state waste. The facility data report shows some of this information in there. In 2012, out-of-state waste comprised of 40% of all of that general municipal solid waste that was disposed of in Ohio, or just over 4 million tons. So that's quite a bit. And this number has been pretty much consistent over the past 3 years. Ohio has been a top destination for out-of-state waste for quite a while. Some of the reasons for this include the large disposal capacity, direct highway and rail access to many of the major landfills, as well as some of the lowest tipping fees, cost per disposal in the country. And the majority of this waste comes from the East Coast, at the top of the list being New York and New Jersey, and most of that waste ends up in landfills on the eastern portion of Ohio or in the Appalachian counties of Ohio. Mike mentioned House Bill 5992 earlier. This was the state legislation that was created originally in 1988 to overhaul the way that the state and local governments manage solid waste in Ohio through state and local plans, basically. And at the time that that plan was created, it was primarily enacted due to the lack of regulation or poor oversight of Ohio's landfills. And I've included a few points from the Ohio EPA's website. They have a fact sheet about it, and some of those I've included here. So at the time, there was decreasing capacity and fewer landfills, increasing amounts of materials from out of state being brought in, and problems related to methane gas migrating from landfills and apparently causing explosions. Since this legislation was passed 25 years ago, things have changed with Ohio's landfills, and primarily due to start of the regulations with this bill. But because of that, Ohio EPA has begun a process. They started over 2 years ago, I think, to revise this House bill to more accurately address the current needs of Ohio. And Mike showed part of the new vision statement, which I've included here as well. And in the process of the OEPA revising this House bill, they've really engaged all of the stakeholders and the public in this process. And there's not really a whole lot officially available in terms of what the revision will look like, but this House bill, or this vision statement does reflect and will guide what that revised House bill will look like. And so I'm not going to read the whole thing, but it's here for you to look like. It's also on their website. But in large part, what you can take away from it is a transition from that focus on managing landfills to the management of materials that maximizes their value through recycling, compost, and reuse, and keeping them out of landfills to start with. As Mike mentioned, it also mentions that Ohio is striving to be a zero landfill state. As far as Ohio is currently going in terms of diverting materials, you can look at the state solid waste plan. And the last time that this plan was updated was about 5 years ago. At that time, the state reported about 3.3 million tons of materials that were generated from residential and commercial sectors were recycled, which was about 25% of the total waste generated. And the industrial sector also recycled about 8.9 million tons, or about 56% of what they generated. I mentioned the BioCycle report earlier, and in 2008, when they generated that report nationally, Ohio ranked about 19th in terms of recycling per tons per capita per year. So Ohio has only continued to increase its recycling since that time, so it would be very interesting to see what the next solid waste state plan looks like. Much of Ohio's success has come from collaboration of those public and private partnerships and a strong industrial sector, kind of pulling the demand for the recycled material. The only way that these efforts can really be sustained or effectively continue is when there's collaboration and a strong focus within that education, awareness, and outreach to the public on topics regarding these issues. Ultimately, the proper infrastructure and services got to be available to capture the material and process them. But local, regional, and national markets are really what help to drive the recycling industry. So understanding and working with these industries is critical. And then to help guide all of that along the way, well-informed policy. And so you've even seen throughout this short presentation that information can be hit and miss depending on where you're getting it from or how available it is. But ultimately, with that information, we can better understand where those gaps are and where we can improve our efforts. So ultimately, to achieve these goals, that, like I mentioned, good data and good information is essential, and access to that information is also critical. But obviously, best practices at landfills, like the ones we've heard about today, are really going to be absolutely necessary with how many landfills there are and the amount of waste that continues to keep on flowing into them. And continuing to build upon that collaboration between folks working in this sector. Everyone sees the value in recovering more materials, as Waste Management had mentioned earlier, and only sharing information and working together is going to improve all of that. But ultimately, this comes down to us at an individual level making personal choices on a daily basis. So I'll close up and I'll open this up, I guess, for questions, Alyssa, and that's all I have to say.
Fantastic. Thanks, Kyle.
Thank you.
I'm going to go ahead and turn this back over to Mike Loong, our moderator, and he'll be fielding some of the questions that have come in from the audience. And I think we've got time for maybe 2 or 3 questions before we need to wrap up here today.
Okay, so this is to either Kathy or Paul. How does the extreme weather, hot or heat or cold, affect your compressed natural gas vehicles in operation? Have you had trouble this winter in Ohio?
Paul, I don't know if you wanted to answer that. I can tell you from the few comments I received from some of our fleet is that when it's extremely cold, we've had some difficulty, yes, with the fuel source.
Anything else?
Yeah, I don't have information on that. I haven't heard anything reported.
Okay. Question for Steve Giles. what is your average gas generation? And I'm not per...
I think that's probably ton of landfill material.
Per ton of landfill material. In other words, that's probably in-place tonnage. How much gas do you expect to generate on the average?
I can't give you a specific metric right off of that. Essentially, if you look at a landfill that produces about 300 standard cubic feet a minute, should get you into about a 1 megawatt capacity range. In general, and again, depending on the nature of the landfill and the age of the landfill, that varies. But just to put it into a mathematical formula, if you look at the Hardy Road, it's 100 acres, and we're in that range. So, 100 acres per megawatt is probably not a bad rule of thumb.
Okay, thanks, Steve. I'm going to go back to Kathy and Paul for a minute, and I'm just looking at some of these questions. I'm going to try to roll this up into a question about what does waste management see coming in the way of alternative waste handling technologies, and what could be done in the state of Ohio to support any solutions, innovative solutions. So when we listen to what Kyle has said about the vision and the need for infrastructure and technological innovation, from waste management's point of view, what do you see coming down the road?
This is Kathy. I think one of the things that the company is seeing across the board is, our investment in some of the technologies that we think may provide in the future the right scale, the right opportunity to generate value from a material. I'll just give you an example. Today, we are working with the City of Philadelphia to build a spec fuel plant, where we obviously will take in the City of Philadelphia's materials, process the recyclables, manage the wetter waste streams, whether they're food waste, organic waste, and then ultimately have a material that has a high BTU value that can be pressed into a pellet, that pellet then becomes a fuel, a spec fuel that could replace the fossil fuels or other fuels that either the city in a municipal power situation or an industrial boiler. So really in the Midwest where we utilize coal, this spec fuel option may indeed be a value for the future. But some of the issues that Kyle brought up really may become a stumbling block when you look at, could we produce that type of fuel pellet in Ohio that would be of use, that we could see as an alternative to landfilling. Of course, some of the materials will still need to be landfilled. Some of the things that Kyle mentioned would be impacting that type of future decision. For example, can you invest in that technology once you scale it, once you figure out it all works, and know that you can return your investment on that, because it's very expensive, whereas in Ohio we do have disposal prices that are less. So you do have the infrastructure that would be needed. It would be costly, and the private sector investments in that are possible, but you've got to make sure you can get your return on that investment. That's just one example.
Okay. Okay. So anything else? Any other panelists want to comment on that? Okay. Let's stick on the issue of organics here for a moment. The question is, and this is to all analysts, do you foresee replacing landfill disposal of organics and landfill gas collection with a more controllable anaerobic digester and gasification? And if you do, would these be large regional facilities, small community-based, and how would that change landfill operation? So basically we're saying let's divert that organic matter away from the landfill, put it into a controlled vessel, controlled system, and make our gas that way in the future. To some degree, that's what you just said, Kathy, I think.
Right, right. I'll take a stab at trying to throw out a few comments in relationship to that. I mean, waste management has and is looking at anaerobic digestion as well as gasification and pyrolysis. They're very, expensive. They're very, we've got to make sure the technology can be scaled so that we can manage the incoming waste that we have to pick up every day, we have to manage every day. These are not small volumes across the United States. But the important thing is, you asked a question, could you look at an anaerobic digester that might serve a particular industry to generate a fuel to service that industry? Just take, for example, in Northwest Ohio, I know the Campbell's plant has done exactly that. We have some other sources in Ohio and other companies that have looked at how can we look at anaerobic digestion and produce a opportunity to manage the organic waste, whether they're coming from a public setting or a private setting, and manage that into a fuel source for them. So I think that you're going to see in Ohio that opportunity succeed. But it all depends on whether or not that individual company or commercial establishment or public establishment wants to invest in that.
Yeah, this is Steve, Mike. I'll kind of follow on that because we did the early stage development of the Campbell's anaerobic digestion project. Campbell's in Napoleon, Ohio is the world's largest soup manufacturer, interesting enough. And they were in a position, they have a lot of organic waste. Their existing waste management practices were needing a significant upgrade. One of the issues that you encounter in anaerobic digestion projects, like any other projects, understanding your fuel, and when you're making millions of dollars investment in energy projects, you want that facility to be able to operate, as at a high capacity level as it can, 90–95%. So that's 24/7, 365 days a year, and so you need sufficient fuel. Their manufacturing process had seasonal aspects to it, obviously with tomato harvest and things of that nature. And so, it became a regional project to bring in a mixed waste stream from some other companies, as well as some newer from local dairy CAFA. So I think we're already seeing anaerobic digestion happening, and it really is a matter of scale as to, there are a handful of processes out there that can be standalone. There are several farms that have done more standalone systems, more distributed generation. We're seeing some that are starting to be regional. And I'll do a shout out to Ohio University because, the other thing that is happening, not only down at OU, but also, some municipalities are doing it, is they're trying to capture their organic waste for composting, again, for a reuse or beneficial reuse of that waste. So I think to your point, Mike, yeah, we are going to see an increasing level of diversification of where those organic waste streams go and how they're utilized.
Mike, why don't we
Thank
have
you.
time for just one more question and then we'll wrap it up?
Well, here's a real quick question to Waste Management. They want to know where you buy the gas. Where do you get the gas, your CNG? Do you get it from your own landfills, or do you buy it from other sources?
The CNG, we've got, I think, 57 CNG fueling stations now across the country, and I think almost 20 of those are open to the public, and they all take their gas from natural gas pipelines. We are in the process now of building our own high BTU plant in Illinois, and there will be some contractual swapping of the renewable natural gas that we put in that pipeline and then transporting it or selling it through the gas pipelines to the CNG fueling stations. So we will, in effect, be offsetting the natural gas that we use with the renewable natural gas that we make from the landfill gas. But at the present time, all the CNG fueling stations are using natural gas.
Okay. Alyssa, we still have lots of unanswered questions. Maybe they can write directly to the panelists.
Yes, I think that's a great idea. If you've got some questions that weren't answered, feel free to direct those to me, but my email, welche@ohio.edu, or through the website at ce3@ohio.edu, and we'll attempt to get those to the presenters here today and get you some answers to the questions that we didn't have time for. But we really appreciate the excellent discussion that we had here and the presentations by all of our panelists and the moderation by Mike Loong. Thanks everyone again for joining us today, and enjoy the rest of your day. Thanks so much.